Hello and welcome, my fellow builders in the ecosystem. My name is Julian Martinez, Senior Developer Advocate at SDF, and your guide for today's journey. Today, we're going to talk about how you can use the Soroban Dapps Challenge to build your very own Dapp. So without further ado, let's open up the Soroban Dapps Challenge and follow along. Here we are at our very first challenge, the Crowdfund Dapp. I'll go ahead and click the Start Challenge button so I can record my progress as I move along. This brings us to checkpoint 0, Install. In this step, we clone the repository, check out the challenge branch, install a pinned version of Soroban, and build a Docker image. Now, I've already done some legwork by doing the first two steps, so I'll go ahead and build this Docker image. What this is going to do is build a container in Docker that we'll use in the next step to deploy a local instance of Stellar Core and Horizon. This brings us to checkpoint 1, where we launch the backend. To complete this checkpoint, we're simply going to run the quick start shell script and specify that we'll be using a standalone network. What this is going to do is deploy a local instance of Stellar Core and Horizon for development and testing. Now that I have my standalone network running, I'll go ahead and hit checkpoint 2, where I deploy the smart contracts. I'll copy this command over and run it in my terminal. So we run a few scripts here. We run the script run clean, which is going to remove our previous deployment files as well as our node modules. Then we run the script setup. This is going to run the initialize shell script, the build contract script, and then install our node modules again. Let's go ahead and follow along in the terminal to see exactly what's happening here. First things first, we set our RPC URL and friendbot URL to align with our standalone network. Then we create a token admin identity. Then we build the smart contracts. After this, we deploy both the Abundance token contract and the Crowdfund contract. Then we initialize the Abundance token with the token admin address, and then initialize the Crowdfund contract to receive the Abundance token. Next, we build the TypeScript bindings for the smart contracts, which are then used in the front-end components. After this, we install our node modules. Now that we've completed this step, I'll go ahead and mark this milestone as completed. Awesome. With that, we can head on over to checkpoint 3, where we connect the front end to the back end. In this step, we're going to run the command npm rundev in our terminal. This is going to deploy the front end of the Crowdfund app to localhost at port 3000. In the next step, we'll add the standalone network to Freighter. So first things first, let's navigate over to localhost at port 3000, and you'll see that there's a spinning wheel here. This is because I've not yet funded my account in Freighter. Now, you can either follow the steps outlined in the checkpoint, or you could set your network configurations to the following, specifically here at this friendbot URL, and then we could simply mint our standalone lumens to our wallet by clicking the Fund with Friendbot button in Freighter. Now that my account is created, you can see that the pledge form is populated, and I can mint this wallet some tokens and back this project. This brings us to checkpoints 4 and 5, where we do exactly that. First things first, I'll go ahead and click this mint button to mint my wallet 100 abundance tokens, and then I'll select this option here and pledge 100 tokens to the campaign. We get this awesome success message, and you'll see here that the balance of the abundance tokens of my wallet has been updated, as well as the amount that has been pledged to the campaign so far. I'll go ahead over back to the Soroban Dapps challenge, where I'll mark this as completed. Awesome. So far, I've shown how to deploy the standalone network, deploy the Crowdfund contracts locally, and deploy the Crowdfund Dapp front end locally. Next up, I'll provide instruction on how a user can use the Crowdfund example as a starting point for building a custom Dapp. In the existing Crowdfund contract, users have the ability to make deposits to a campaign, and the recipient can withdraw those funds if the campaign is successful. Now, what if a user wants to customize this contract and transform it from a simple crowdfund into a crowdfund token offering? In this new scenario, users would make deposits, and once the campaign achieves success, they can claim reward tokens equivalent to the amount they've deposited. This means that the reward token would hold the same value as one of the deposit tokens. Next up, let's talk about how a user can customize the current contract to align with a crowdfund token offering use case. In this diff, we'll cover the modifications made to our crowdfund smart contract as we transform it into a crowdfund token offering contract. As you can see, we've introduced some new elements into our data key. First, we've added the reward token field. This will represent the token users receive as rewards once a campaign is successful. Additionally, we've created a user claim field to track whether users have claimed their rewards. We've also added getter and setter functions for these values, and we've added a new function, which is transfer reward. When a user claims their rewards, this function will transfer reward tokens from the contract to the user. Next up, I'll cover the changes made to the initialize function. We've added the reward token parameter, so now we're tracking two tokens, the main deposit token and the reward token. We also set this value to the appropriate key in the data key. Next, we make a change to the deposit function here. Every time a user calls the deposit function, we set user claimed to false. Then, we increase the lifetime of the storage of this contract by one ledger. To do this, we call storage, instance, and bump. This will ensure the persistence of the data for the smart contract during its lifetime. Next, we have our recipient claim function. This is the same logic from the withdraw function from before. Here, only the recipient can call this function and will transfer the deposit tokens over to the recipient wallet address. And here's the exciting part. Users can now claim their reward tokens with the claim function. We've implemented a mechanism to prevent users from claiming rewards if getUserClaim returns true. Once they've claimed their rewards, the contract sets their deposit amount to 0 and sets user claim to true. We then ensure the persistence of this data by calling storage instance bump and specifying one ledger. Next up, we'll see how we can configure the front-end components to align with this use case. First things first, let's deploy the new crowdfund contract and build the TypeScript bindings. To do this, I'll specify that I'm using the standalone network, then I'll run the command npm run setup sale. Just as before, we're running npm run clean, which removes our previous deployment files, and then we're going to run initialize sale, a shell script that deploys all three of our contracts and initializes them. Then we're going to build the TypeScript bindings using npm run build contract sale, and then we're going to install our node modules by running npm install. Let's follow along in the terminal. Again, we could see here that we have the RPC URL and friendbot URL pointed at our localhost instance. Then we create a token admin identity. We fund that admin account from friendbot. We then deploy the abundance token, reward token, and crowdfund contract. And then we initialize the abundance token and reward token with the token admin address. And then we initialize the crowdfund contract with the deposit token as the abundance token and the reward token as a reward token. Next up, we fund the admin address, and then we make a transfer over to the crowdfund address. This is done so we can create reserves in the crowdfund address of reward tokens to send to pledgers after the campaign is successful. Once we complete the initialized sales script processes, we then move on to building the TypeScript bindings. After this, we install our node modules. Now that the new contracts have been deployed and the TypeScript bindings have been generated, let's go ahead and update the front end. Let's start with the campaign description. Previously, our description described a Starfund initiative on planetary open source photography, but now we've changed it to introduce Soroban, a DAO focused on community-driven governance and secure, transparent decision-making. Next up, we've changed the cover image from a picture of Neptune to the Soroban logo. Now let's take a look at the form pledge component. Let's go ahead and start at the top here with our brand new import, the claim button. This component allows users to claim their rewards. This component takes in two props, the account, which is the user's wallet address, and onComplete, a function that's called once the claim process is finished. We've wrapped the claiming logic within an async function called handleClaim. This function attempts to execute the claim method and either completes the process or throws an error. The button itself is rendered within our custom button component, and the handleClaim function is triggered when the button is clicked. Next up, we've got to add some new state variables to handle reward balances. We'll use React's useState to create variables for the reward balance, the number of decimals to display, and the reward token symbol, like so. Moving on, we need to use useEffect to fetch the reward token balances for the account. Now, we'll make this information visible. In this section of code here, we'll add a new div section to display the user's reward token balance. And last but not least, this is where the claim button comes into play. We'll add it to the component so users can actually claim what they've earned. Let's go ahead and have a look at the new updated front end. I'll run the command npm run dev in my terminal again to see the locally deployed front end. Alright, so here's the new front end. First things first, you'll notice this awesome new claim button. You'll notice that we now show the user their reward token balance, and you'll see an updated project description and the logo for Soroban. Next up, I'll show you what the claim functionality looks like from a user perspective. I'll start by minting tokens to my wallet just like before, and then I'll use those tokens to back this project. It's important to note that this function is just here to demonstrate the feasibility of using a specific token to deposit to the campaign. Theoretically, a developer can initialize this contract to receive USDC, XLM, or any other token available on Soroban. Now that that's covered, let's go ahead and move on. We'll do our mint, and I'll get to 200 tokens in my balance. Then I'll go ahead and back this project with those 200 tokens. Awesome. We have our success message here. Our abundance token balance has been updated, and we see the pledge campaign updated with the amount that has been deposited so far. Now let's go ahead and open up the console, and I'll click this claim button. I've just approved the transaction, and we see a reward claimed message here in the console. I'll do a refresh, and boom, you can see that the user's reward token balance has increased to 200 tokens. And that wraps up the demonstration with the new and improved crowdfund token offering contract. In this demo, we successfully transformed our original crowdfund contract to a crowdfund token offering contract, and we made updates to the front end to reflect those changes. The rest of this challenge entails that you deploy this Dapp to FutureNet and host it on Vercel. If you'd like to complete this challenge, you can simply pick up where we left off and complete checkpoints 6, 7, and 8. I'd like to thank you all for joining me in today's session, and as always, if you get stuck, you can review the Soroban docs or reach out in Discord in the Soroban help channel. Once again, I'm Julian Martinez, and until next time, happy coding.